Hi everybody. So once we have all our software installed, we're ready to go and start doing some processing of the data. And to start with, we would go with calibration first. But to do that, let's just copy paste our props folder. It could be called anything, whatever you find useful in your production. In this example, we're just going to call it props. And in this folder, what you'd see is this rig dev cam file. That's basically pre-calibrated file, rig definition file that comes with our rigs that we ship. But it's better to adjust these values and make sure that after you install the camera and all the lights, that everything is in order there. And we have special tools for that. However, when doing that calibration, it's important to have focal length of the camera, or I should say of your lens. And the problem there is that even when you use prime lenses, and let's say it says 55 millimeters, in reality, depending on what you're focused at and what that distance is, the focal distance might change a bit. Yes, that's some people don't believe that, but that's the thing. So to calculate, to have a proper, more accurate calibration there, we would use photogrammetry pipeline and calculate that value, what the actual real value is. So for that, let's copy our prop template and call it chart. So this is going to be our test prop that we'll use for photogrammetry. Let's go to all our capture folder. This is what got copied from the camera when we did all our captures. So we have our mirror ball that we'll use for setting the calibration. It's also useful to adjust the scale of these thumbnails a bit so everything is aligned here. And this is, we have our color chart and an octopus prop that we'll be processing later. So let's grab all those color chart images and paste them into our under props chart under EOS folder. Just copy in here. So the next step, and this is true for processing all of the data from now on, the first step is to run full EOS file script. What that will do, it will look at the EXIF information and at the rig definition file and place everything into folders where you would have files that are organized in a certain way. That's easy to automate with the rest of the scripts. So in these files, if we look at actual EXIF data, all that is preserved. We have our resolution, 9504 by 6336. We'll need to remember that. And this is the thing what I've been talking about. Focal length, it says 55. It's a full frame camera. It says also 35, equivalent 55 millimeter, but we'll see that in reality it's a bit different there depending on your focus and distance. So now let's go and run generate PG image script. And this script, what it does initial pre-processing and material estimation, and it generates synthetic images for photogrammetry process that we use. And some images are optimized for alignment process, where it tries to remove all or like as many view dependent effects, lighting effects as possible. And other images are more suitable for more accurate and higher quality depth map and geometry reconstruction. And in this case, it's good to have beefy CPU. We're using 32 threads in this case because this can take a while sometimes. So now it's generated. We go to PG folder, and it stands for photogrammetry process. And under images, we would see that we have all our baseline images that are generated that we can now use with our photogrammetry software. Could be reality capture, Metashape, Zephyr, you name it, doesn't really matter. So at this point we will be using as a starting point reality capture. So we have a useful script, start reality capture. Now under add imagery, add inputs, and let's go ahead and add our images in here. One important thing that distinguishes this photometric process from just regular photogrammetry is that in regular photogrammetry, when we throw thousands or hundreds of photos at it, if something doesn't align quite well, it's not a big deal, because later when textures are built, there are different techniques to prevent misalignment there. However, in photometric process, we want all our cameras and all our pixels to be as perfectly aligned as possible, because we could reuse that data. And so we pay a lot more attention to alignment and calibration settings than you normally would for photogrammetry process. And one important thing when we set it up in reality capture, that is true for other packages as well, is that when we go to an image, we would see that calibration group is 0 and lens group is 0. And that's very important, what it tells, and clicking at all the images, we have the same one. And the way that works, by default, when you just import images, you could have a situation like this, where all these images would have camera group -1 and lens group -1, so it's not unassigned. And when we click through all these other images, they all essentially have unassigned groups. And what that tells photogrammetry software is to optimize lens parameters independently. And that's a good thing when every single shot has its own focusing point. But in this case, we basically shot everything in manual mode, manual lens focus, so we know that all parameters should be the same. However, right now, when nothing is grouped, let's go ahead and run the alignment process. So one problem that we see right away is that we have 3 different components here. Some cameras are misaligned, and this is not something that we can really use reliably. So there are, at this point, different ways to deal with that. We obviously cannot proceed like that. And the first thing that we're gonna look at are alignment settings, and 2 important parameters that might affect that are image overlap, here it says set to medium, and also detector sensitivity. And sometimes the bigger is not better. So let's go ahead and change detector sensitivity to low and try to run the process again. That's still not good. Some things got aligned, others are not aligned. So let's keep going. Let's try low overlap. Oh, there you go. So we got something that looks quite a bit better. Let's scale our camera. So we get our cameras, and this is a very important thing. As I said, we shot everything with a turntable. We know that all cameras must be the same distance to our object there in the middle, and the focus was the same. However, here on the right, when we hover over those shots, you would see that we have focal, that comes from the EXIF information, that's what the lens says on it. But to the right, we have actual estimated one. And as we hover through, we have these values all over the place. 58, 64, 65, 63, and so on. And if we look at this screen from the top, we can clearly see that some cameras are further away from the center, others are closer. Then we have this one outlier camera that is completely off. So even though it says that everything is aligned, it doesn't mean that it is actually aligned or it's any good. So, and this is where this other thing I was talking about comes into play. So right now these cameras, once we added them, the first thing we want to make sure that they're all grouped based on EXIF, or you have some custom cameras and some EXIF information that's not reliable. You would have to manage all that manually and then assign those values manually. So the easiest thing to do is to really just assign, click on images here and assign and click a group button, and that would assign them. Here told us at the top right that assign 12 images to a single group, and we could verify that. If we click through them, we should see that now it's calibration group 0 and lens group 0, and essentially what it does, it looks at EXIF information of every image, and if it detects that it's shot from the same camera with the same parameters, it will assign them to the same group. So this way, when the optimization process during alignment happens, it will treat them as one single unit, and that way it will be able to derive much more accurate values. To make sure that every time when you import something you always get that assignment automatically, it's useful to go to workflow settings, and under input settings over here you can set group calibration by EXIF yes. And that so next time when you add images, it will do that grouping automatically for you. But you always need to check that. Sometimes, let's say when working with TIFF images, they do have EXIF information, but it will not be imported properly, so you have to pay attention to that. Anyway, right now we got that assigned, and let's run our alignment process again. And as you can see, we changed one thing that was not related to alignment, and all of a sudden again we have 3 different groups, and that's not good. We cannot proceed like that. Let's run it without changing anything at all. Oh, look, now it got better. Now all of a sudden, instead of 3 groups, we got 1. And let's look at our cameras, and there you go. We have perfect circle there. If we hover over those images, we can see that the focal estimated proper focal length is 61.65. We should write that parameter down. We will need it later. Let's put it in here, 61.65. And as you can see, though the lens says it's 55, in reality, because when we focus, and you could see it with yourself with your own lenses, if you focus on something that's close to the camera, you would have one field of view. If you see something that's further away, that's going to be a different field of view. So let's have that file sitting there, and we will need it later. So at this point we know the focal length, and we can proceed with our light calibration. We don't need this file anymore, so we're not going to save it. We just needed to get this parameter here. So now if we go to captured folder, we got our 24 shots of the mirror ball. And in our specific case, even though these lights can go in any order, in this framework there are many places where it expects currently this specific order of lights. So that's important when you connect everything together to make sure that your mirror ball sequence would look very similar to this one. So let's grab all our photos, go back to scans, utils, light positions, EOS, and drop all our files in here. Run full EOS files, and at this point it's enough information for us to now open Blender and proceed with calibration. While it's opening, let's go to one of our files, as we will need image resolution here, So it's 9504. Let's go to move this a little bit. Let's go to here. It should be 9504 by 6336. Done. Now click on camera tab, and here we have, first we need to select a particular sensor type that we use. In this case we know that it's a full frame 35mm camera. It's Sony Alpha 7 R4, and let's specify our proper estimated focal length, and we have it written down here, 61.65. let's punch it in focal length. There you go. And as you can see, we can close that file. If we go from 55, that was 55, if you look at that image on the left, and 61, so there is quite a bit of change, even though it's not a big difference, but there is a difference. So if we want to be more accurate, it's better to do that estimation step. If in your case it doesn't change too much between these values, you could probably directly go with light calibration, skipping all that estimation step with photogrammetry. So we punch that. The next thing, we need to make sure that our mirror ball, if we click on it, it matches dimensions of the mirror ball that you use. So essentially you need to go and measure diameter of your mirror ball and punch the same number in here. Let's say if yours was 50mm in diameter, you'd go and do something like this. In our case it's 65. I know it's been measured 65. And now the idea is that we first need to align this virtual mirror ball with the one that we have in our images. So this is where it can be a little bit tricky to see it. In this case it was photographed with the same black background, so it might be a bit harder to do. If you shoot yours, make sure to also put some colorful background just for this case, so this step would be easier. Also, when we shot that, I pointed out that it's useful to have this mirror ball align as close to the optical center of your lens as possible, so that this alignment later on would be a little bit easier. So in this case we can go and sort of switch between change this blend parameter between the scene and the photograph, and we can clearly see in this case that these are extents of our real mirror ball in the image, and the virtual one goes quite far. So what we need to do right now is to move this mirror ball along the z-axis, closer or further away from the camera. In this case, in Blender, I hope you can see all these shortcuts. I click G and Z, and by moving it back and forth, we can make sure that it's the same size. I think that should be pretty close. And now, while I'm in this window on the left, I can press G in Blender and just move it around until it aligns, and we try to do it the best we can. I think that should be pretty good. Let's switch to camera and play with opacity. So I think that's a pretty good alignment, and you see that already our pre-calibrated highlight there is pretty close. Even if we didn't do this step, it would be fine. You probably won't see many issues, but it's still a good practice to go ahead now and move all lights around. So down here at the bottom we see the timeline. In this, it basically goes and switches from all those different shots in EOS folder, and it enables different virtual lights that we right now want to adjust. So we click on one, click on the light, and while this cursor in this window on the left, we press G, and we can quickly move it around and make sure it aligns with the actual highlight in the image. Then go to the second frame. You see that one was pretty close. Number 3 is really close. Number 4 is, again, it's pretty much there. Number 5 is a little bit off, no problem. Number 6 a little bit off, moved. 7, done. 8, done. Number 9 is quite a bit off, it's moved. This one is pretty close to 11, no need to move. And 12, let's move it a little bit more. So now go to 0 frame, and you can see that pretty much we got all our calibration done. If to you it might look a bit distorted, that partially the reason is that when you mount the camera, if it's tilted a little bit up or down, because this is essentially projection on the rig's grid, that whole thing might stretch. If it's tilted left or right, this thing might be a bit deformed from left to right. If the camera is tilted up and down a little bit, then this thing can be tilted as well. And this is the reason why we do this calibration, just to move things a little bit closer in place. So in this case, everything is pretty much done. We can save the file, and now we need to export this script. In here we have already this export script available. We can click a play button and it will do the trick. Another way is when we go at the top here to scripting tab, we can see this is our template that we'll be using for exporting. So this is when you're using custom rigs, you can predefine everything here. You could have more than 12 lights or less than 12, but essentially we run the script, it will export the file, and it will open us window and with that file selected that we just exported. So now we can just cut it and paste into our props folder. This was our original pre-calibrated file. Let's just rename it, call it old or regional, whatever, and paste our new file in here. So great, at this point we have our rig calibrated, so once we start doing all the photometric processing, it will know how to treat those images and where those virtual lights are. Another important thing is that in here it also describes how those photogrammetry images get translated into that whole structure. One parameter that we might use or change later is this frame mask pattern. And that essentially defines mapping between actual file names that are used in photogrammetry process and their masks. For instance, in reality capture, by default there is no suffix or anything like that, so it would be basically the same name but in PNG, and that would be considered a mask. In reality cap or in Agisoft or Metashape pipeline, we're using a separate folder where we put files in there and add this underscore mask.png to them. So this all could be changed, but at this point we got our file. We don't need this Blender file anymore, so we can close it, and we don't need that either. So at this point calibration is finished, and I'll see you in the next video when we'll start building actual assets and materials.